Great news, everyone. Straight after I uploaded the latest Spike Prime video, Python is officially out of early access, which means it is now available to everyone who uses the latest version of Spike. So if you haven't already, go and download Spike version 3.3.1 or use the web app at the link below. Today, I'm teaching you part 2 of how to code Spike Prime in Python. And by the end of the video, you will be able to make your robot respond to sensors, such as making accurate turns using the inbuilt gyro sensor, detecting an obstacle with a distance sensor, or detecting a bump with the force sensor. Now let's start with the most requested tutorial, how to turn accurately with the gyro sensor. Now keep in mind that I will post all of the code from today's lesson into the GitHub link in the description. So forget everything you know about using the gyro to turn your robot from previous versions of Spike Prime, because it has completely changed. Let's have a look. So first of all, let's load up your latest version of Spike, create a new project. Today we're going to call it, I don't know, Python Sensors. Make sure the Python selection is click create. And then, now in the past we had to create objects for all our motors and sensors and things like that. Now in the newest version of Spike, it's a little bit different. And if you ever need any help, make sure you check out the knowledge base in these links over here. First thing we're going to do is we're going to import some things. Okay, so we're going to go import motor and import, yes, actually import motor pair. It should be the one we want. Import motor pair. And then we're also going to go from hub, import port. And then we're going to also include our motion sensor, which is the inbuilt gyro sensor, and they call it the motion sensor in the library. So we go from hub, import motion sensor, and you can just hit enter when those prompts come up, save you from typing a few extra things. Okay, so we have our motor pair, we have our port, and we have our motion sensor. That's a good start. Now, in where we write the code, straight after we write hi on the light matrix. Now, if you don't want to have this write hi, you can just comment it out using the hash symbol. We're going to turn our robot so that it is turning 90 degrees. Okay, so first thing we're going to do is we're going to reset the gyro sensor. Okay, so we go motion sensor dot set your face, and then we're going to go motion sensor dot, I'll just get rid of this, motion sensor dot front. Oops, capitals. Okay, what's this doing? In the latest version of Spike Python, your direction can be customized. So you can change the your face of your robot. Doesn't have to be the same face that you're normally sort of turning with, this sideways kind of face. So if you look at your robot, usually your robot the your value is this turning angle, right? But if you wanted to, you can set the face that is facing up to be a different face. So right now we're using the default your face, which is this front face is facing up, but you can also make the top face facing up so that it is like this, and then the your angle is now this angle. Okay, but don't worry about it for now. It's probably going to factor in when you design a very special robot. But for now, we are going to use this default your face. Okay, so motion sensor front. Then we are going to go motion sensor dot reset your to 0. Okay, so this is telling our robot that before we are turning, we're going to set whatever the direction it is facing now as the 0 point. Okay, that's looking good. Now we're going to turn left 90 degrees. Okay, so right here we have reset everything. We are resetting the yaw angle. Ooh, I'll also set our motor pair. So here we go, motor pair dot pair, motor pair dot pair 1 dot port C hold on, pair 1 comma port C comma port D. Now this is sort of like what we used to do for setting the movement motors, but this is a new pair function here. It will prompt you to tell you what you're supposed to put in there. So when you hover over it, it says that we need to put in the pair integer, which is pair 1, and then we have to put in the left motor and the right motor port. So that's why we needed to import port right at the start. See, from hub import port. All right, so now we have set it. Now we are going to actually turn 90 degrees. How do we do that? We're going to use a while loop. So while motion sensor dot tilt angles returns the first value 0 is less than 900. Okay, so 900 is actually decidegrees. So it's an integer, but it has to be 1/10 of a degree at a time. So if you want to turn 90 degrees, you have to make it so that while the motion sensor is detecting that the first yaw angle is less than 90 degrees, and because each one unit here is 1/10 of a degree, we now need to put 900. Okay, so while that is the case, motor pair dot move, and then we're going to put in our pair 1 again. Whoops. Motor dot pair motor underscore pair dot pair 1. That's why it wasn't uploading. And then we are turning to the left, which is actually going negative 100. Finally, once we have reached that angle, 900 decidegrees, we're going to go motor pair dot stop, and then stop what? We are going to stop motor pair dot pair 1. Okay, there was a lot of code in there. Let's run through it a little bit slowly. Okay, what are we doing? Okay, right at the start here, we have just defined our motors. Okay, over here we reset the yaw angle, and then over here, why are we using this this funny notation where we have square brackets and 0 inside? This is getting the first value of this sensor.tiltAngles function. Okay, so the sensor.tiltAngles function, if you look inside API modules, go check out the hub motion sensor, and then if you look for tilt angles, it actually tells you that the return of this comes back as a tuple. Okay, a tuple is a kind of Python list that is uneditable, and it comes with 3 numbers. Okay, if you want to grab the first number, which is the yaw value, see, yaw, pitch, and roll. So you want to get the yaw value, you have to go the tuple, which is this tilt angles, and then square brackets 0. Okay, that's getting the first value, which is the yaw value. If you want to get pitch, you have to put the number 1 in here. And then if you wanted to get the roll, you have to put the number 2 in here. And I talk about tuples quite extensively in my Python tutorials, and I'll talk about that later on in the video. All right, so we are getting your value from a tuple. And then once it is less than if it is still less than 900 decidegrees, so 90 degrees, then we are turning towards the left. Now, inside the latest version of Spike, when it's turning to the left, the yaw angle actually increases positively. Okay, so it goes towards 90 degrees. So if you imagine that it starts off at 0, then it starts turning, then it's 10 degrees, 20 degrees, 30 degrees, all the way to 90 degrees. Okay, when it's turning to the right, it goes negative. So negative 10, negative 20, 30, 40, negative 90 degrees. Okay, so we are saying that when our tilt angle is less than 900 decidegrees, so it is still facing forward, we are turning towards the left. Okay, but then eventually we are going to hit this 900 decidegree value, in which case we break out of this while loop and then we do this. We stop the motor. Okay, move to left, stop motor. All right, let's connect it up and see if it works. So I'm just going to turn on my hub. All right, it's connected. Now let's run this code and see if it turns to the left. So it says hi, turns to the left 90 degrees exactly. Okay, let's take a look at it again. I just hit play. Hi, turns to the left 90 degrees. Let's have a look at the code again. All right, so this is turning to the left 90 degrees. If I wanted to turn 45 degrees, all I have to do is change this, okay? I say change it to 450, then it will turn to the left 45 degrees. I'll have a look over here. Okay, turns left exactly 45 degrees. But of course, we want to turn it 90 degrees just for the sake of the exercise. Now, what if I wanted to turn towards the right? Well, that's an excellent question. So what we have to do is do the exact same thing again. So all we have to do is we go reset the yaw angle, but we don't have to change our motor pairs again because the motor, because the motor pair is the same. So we go reset the yaw angle, and then instead of turning to the left, turning to the right just means that you have to reverse a few of the signs. Okay, so here we go, turn to the right, 90 degrees. And then when the motion sensor tilt angles 0, that's still the same because this is the yaw angle value. Instead of less than 900, we're going to make it more than negative 900. More than negative 900, then we turn towards the right, which is a positive 100 turn, and then we stop the motor. So now, when we run the code, it's going to turn to the left, stop the motor, reset the yaw angle, and then turn towards the right. Okay, let's hit the play button and see if it does what I said it will do. It's high, turns to the left, turns to the right. Okay, 90 degrees, very accurate. Now, in case you didn't know, I have made hundreds of technology videos ranging from Lego robotics to Vex to Raspberry Pi and even 3D printing, and teaching technology is my full-time job. So if this video helps you out in any way, then please consider liking and subscribing to the channel. You can also join our Coding Essentials membership that gives an extra 269 hours worth of Scratch and Python coding classes. So remember that thing I said about tuples? Well, I actually have hours upon hours of lessons where I explain what tuples and the different collections are in Python. So definitely check that out if you are keen to learn more. Simply click on the join button to find out more below. Okay, now that we have the robot making accurate turns, it is time to detect an obstacle using the distance sensor. And luckily, it is not as complicated. So let's take a look at that. We have now got our code here, turning left and turning right. I'm going to just comment out our code. And if you wanted to uncomment, then all you have to do is remove those triple quotation marks, right? We are now going to look at our distance sensor. Make sure you have built this the same way as the instructions in Spike Prime. If it's not built the same way, then you're going to have to make sure you change your values to be the same. Okay, so we go back up to the top here. We're going to import distance sensor. And you know what? We're going to import the force sensor as well because force sensor. Why is it not force sensor? Okay, because the next two tutorials are a little bit easier than the accurate turns tutorial. Okay, and then we're also importing some sound as well from hub import sound. Okay, so what are we going to do with our distance sensor? We're going to make it so that our robot moves forward until it detects an obstacle and then stops the robot. Okay, and the pattern is very similar to detecting the correct angle. Over here, we're going to go move forward until object within 10 centimeters. While true. Okay. We're going to make it so that this loop is happening forever until we decide to break out of it once we detect a obstacle that's coming close to closer than 10 centimeters. Okay, so here we go while true. If distance sensor dot distance at port F. Distance port F is more than 100, or distance sensor dot distance port F is equal to -1. Let me explain why I'm doing this funny thing. I need to just make this a little bit smaller. Okay. All right. So the distance sensor on your new version of Spike Prime, what it does is it detects the distance from the closest object in millimeters. Okay, but there are also cases where it will return an error because it is a sensor. It is not infallible. What kind of errors can you expect? Imagine if you've blocked the receiving end of your sensor, or maybe an object is too close to detect properly or too far from the range of the sensor, then it will actually return a value of -1 millimeters. -1 millimeters is an error, and it doesn't make sense for us because how can a distance be negative? It have to be crashing into the sensor, right? So what I'm saying here is that if the distance from the port F distance sensor is more than 100 millimeters, so further away than 10 centimeters, or if it is an error, okay? If it is an error or if the object is further than 10 centimeters, what we want to do is start moving. Okay? Even if there is an error, because the chances of an error happening are quite high. Okay, the chances of the not being anything in front of the robot just being clear and it's beyond the range of the sensor, that will also return an error. So that is why we're having a while true loop, and we are having this this special condition here where we're detecting the distance if it's more than 10 centimeters or equal to -1 millimeters. Okay, then we go motor pair dot move motor pair dot pair 1, and the steering value is 0. Else, so if there is an object that comes within 10 centimeters, else we're going to tell this motor to stop, and then we have to break out of the while true loop. Okay, so we go motor pair dot stop motor pair dot pair 1. Get faster and faster as we go along. Oh, we don't need to have a value here. Okay, and then we break. Okay, break means that we are exiting out of a loop. Let's look at this again. So move forward, stop robot, and this is to break out of the while loop. Okay. So here we say, after you've detected we're breaking out of the loop, what do we want to do next? We want to stop the motor. So we go motor pair dot stop. Motor pair 1. Okay. Now let's test it out, see if it works. I'll press the go button. Okay, so it moves forward until it detects an obstacle in front of it. Let's do it again. It's moving forward and stop. Right? And this is very handy for detecting obstacles in your robot game, or to respond to it in a special way. It's very, very fun, very, very handy to use. Okay, the final tutorial is to use the force sensor. The force sensor, of course, is this little one. Just move this up. It's this little one on the side of the robot. So let's do that. Go back into the code. Again, I'm going to comment out our distance sensor code. You can uncomment what you like. And then finally, we're going to do our force sensor code. What we're going to do, we're going to say make a beep when force sensor is touch. It's going to be a nice simple one, because we've been focusing a lot today. This is a pretty difficult tutorial, so I'll give you an easy one to end this on. Okay, while true, if force sensor dot pressed in port A, all we have to do is go sound dot beep. Whoops, no star in there. Beep. Super simple. Let's have a look at this. Run this code. All right, so when I hit the force sensor, it makes a beeping sound. See? Very simple tutorial, just to end today's lesson. I want to thank the sponsor of today's video, More Educational. Ever since Creator Academy started making LEGO education videos, we have been greatly supported by the experts at More Educational. They're an authorized partner of LEGO Education with over 25 years experience working with LEGO education products. So if you're in Australia and you want to buy genuine LEGO education products like the ones shown in this video, then make sure you check out the More Educational website. That's it from me today. Next lesson, we will look at how to make your Spike Prime robot follow a line accurately using Python. I'll see you later. Bye-bye.